Okay, welcome to week 5. We're going to talk about sessions. Couple things I want to talk about when we think about sessions. We need to talk about the words and what they actually mean. All right, so I'm going to show you some stuff, and I probably should not. So bear with me. I'm going to go to some sites, and we're going to look at things, and we're going to see things that you may be able to see, maybe not be able to see. Okay, so I click on YouTube Studio. And I look at my content. This is my content. I'm logged in, and this is what I have access to. I don't have access to your content. This is what we think of as authorization. I only have access to my content. Now, if I switch the user, oh, I have to log in for that. I don't want to do that. Let me create another, oops, I did it right. I executed it poorly. So I can do it this way, switch it from the browser perspective, go to channel dashboard, bang. You can see my content. Here's all the recordings for all that I've made at Roosevelt, right? It's just a different account. So how do we manage accounts, right? How do we do that? How do we do that? How do we associate these requests with things I want to do? Now, there are two separate parts to this. We think of this as authorization and authentication, okay? And you go, what do you mean? Okay. I hate logging into things in front of students. So I'll log in something that's not important. Um, I don't know. What's a simple thing I can log into? Hmm. Do, do, do. Google. No, 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 no. Do I have any something I can simply log into? I don't think I do. Um, hmm. I have an idea. They go to my Amazon account. You see, I'm logged in as Michael. I'm not really logged in. It's still going to ask me for authentication issues. Authentication is how do I identify myself as myself, right? How does the universe, the computer, understand that Michael Ruth, me, is connected to the computer? How do I prove to the computer that I am Michael Ruth, right? I have authenticate authorization. And if you look up authorization, right, versus authentication, authentication is the idea that you're verifying the true identity user, while authorization is determining what you can do. Okay. How can you do it? Well, hoping this will give me an explanation. Nope. Yes, I know. That's the basic simple. Nope. Okay. So I want to talk about basic authorization and authentication. And yes, here we go. Ways in which we can identify that we are who we are. And I'll make sure you have this. In fact, that's why I created this. I'm actually going to create a list of um, links, and I'm going to create them in this new folder that I just created. So one way to do that is what you know. And what you know is a password. So we give you a password. Let's say your password, your username is Bob, right? That account's name is Bob, but we have to have a way to identify that Bob is actually Bob, right? Bobbert Bob, Bobbert Bob Bob. How do we do that? Well, we can give them a password. And if they remember the password, something they know, they can log in, right? They present that. Oh, that's how we know. If you think about it, when you had a tree fort when you were a kid and you said, well, you have to know the password to get in, this is that. This is authentication, knowing that you belong here, knowing that you are who you say you are by passwords. Okay, that's one way of doing it. Another way of doing it, and you realize I'm not reading this in the going one-time password token, right? The other way of doing this is something you have. Okay. Okay. Something you have. So we can provide a mechanism for you to get something and then use that something to log in. So one-time password is an example, but you have to have an email or some delivery mechanism like a text message or a email or some physical access token. If you have that physical access token, you can get in. Like when you go to your door and you unlock the door, you have to unlock the door with the key, right? And that's how you authenticate that that you are who you are. And the final one, of course, is you are who you say you are because you are who you are. This is what we think of as biometric, right? Think about fingerprint. Think about retina scan, hand scans, use your face. Um, funny thing about the face unlocking. Many people were using the face unlock feature of Apple, using the face recognition of Apple to unlock their phone. So girlfriends would go up to their boyfriend's phones. Um, excuse me. Girlfriends would take their boyfriend's phones and while their boyfriend was sleeping, put it in there and then unlock it that way. Not ideal. Now, one other type of mechanism we're going to talk about is what we call multi-factor. And that fourth one is not on its own. Multi-factor just combines multiple forms of authentication. So when you log in to your email address, you're frequently addressed with a username, that's your email, and then a password. And then you get 3 challenge questions, which I help you. Those are multi-factor authentication, but both of those are what you know. Okay. If you suggest, I don't know if it'll automatically log me in. Let's see. Yeah, I'm automatically logged in already. I think I'm automatically logged in. No, that corresponder opens up no matter what. Obviously, I'm not going to log in front of you. Yeah, I'm already logged in. That's why it's not doing it. If you say, hey, you use your username and use your password, and then you log in and say, hey, I want to email. I want not email. I want you to send me a text message or call me. You have to have the phone in order to get that text message or which call. That's a have. And so that's multi-factor authentication. Multi-factor authentication does not need multiple types. You can just simply use any of the types in combination with each other. So that's what authentication is. Authentication is identifying you to be and who you are. Now, why do we do that? When we think about a modern web application, and I'm using YouTube as an example because I have no content in here. I erased all the things that I actually have in here. Um, what am I doing? I'm storing videos and making them accessible for everyone else, right? I can create videos, I can modify videos, I can do analytics on my videos, all those different things, because this is a web application that's allowing me to do that. Note, of course, that I'm not allowed to access Bob's files, right? I'm only allowed to access mine. Hence the idea of a password. We log into an email account. We can look at the emails that we have, and then we can respond to emails and so forth. That's part of the application flow. But I can only access my emails. I can't access your emails, right? I can only send and receive emails, right? From me, right? So when we think about web applications, that's basically how it works. Blackboard allows me to make sites content available to you, and then you can grab it. Very, very simple. Authorization, on the other hand, is identifying who can do what. So now that you've already logged in, we can identify who does what. I'm definitely going to share this with you because this I can read directly off. And how do we identify what you can do or what you can't do? Well, we typically have access control models, and there are some basic ones that we're going to talk about. The most important one is the discretionary access control. This is the easiest one to understand. It's my ball, and I get to tell everybody who does what with it, right? If I don't want Bob Bobbert playing my ball, he doesn't get to play with my ball. I get to say what happens to it. This is what happens in YouTube. As I create a video, I can specify if it's public, private, unlisted, what have you, and only share it to people I want to share it with. Ta-da! Discretionary access control. It's obviously the most simple. I'm going to skip mandatory access control. I will come back to it though. Mandatory access, or excuse me, role-based access control is used to enforce access controls defined in the DAC or MAC model. RBAC builds on it by defining roles and privileges, assigning users to roles, and configures a system so that only specified roles can access each object. Wait, what? So typically, role-based access control is not done on its own, okay? Role-based access control is done in conjunction with the discretionary and mandatory access control. Then you go, what do you mean? So I have a course. I'm the instructor. I have an instructor role. As an instructor role, I can look at your grades and I can look at everybody in my classes' grades and so forth. You can look at your things and the stuff I made available to you as the student, but you can't look at other people's grades and so forth. So discretionary access control is absolutely part of most models. However, role-based provides roles, a way of defining access control based on the role that you play. For instance, instructors get this set of privileges and users get another set of privileges, or students get another set of privileges, as an example. Mac is a little bit more complicated, determines authorization entities at the operating system level, typically governs permissions for threads, processes, and defining what memory objects they can access. Now, Mac is useful, but remember, Mac is generally applied across operating system focus, and it identifies what the processes and the system can do. It's not usually application level stuff. Attribute, I'm not familiar with it. Oh, policies. This is defining things based on policies, and it uses attributes to define those policies. It's basically an access control list. You identify what can be done and what can't be done, and you set attributes on things, and that helps provide a mechanism to determine whether or not you can do the things that you want to do. All right, I'm going to leave it at that. We don't need more than that. That is a very good primer. But authentication authorization isn't the only thing. And you go, what do you mean? Let me show you something. And you're going to not be that, well, maybe you'll be surprised. Y'all know how Amazon works. Yes? So very first thing I'm going to do is log out. Yep, nope, don't want to log in. I just want to log out. Okay, so now I'm not signed in. Yay! And now let's look at, I don't know what this is, so let's look at this. Sport umbrella. It's a universal umbrella with a clamp. Yay! It seems really stupid. Oh, okay. No, it clamps onto things like, your chair and stuff like that, and you can stay cool under a thing. Okay, so I'm going to add, that seems like a lot. So I'm going to add that to my cart. Okay. Note I'm still not logged in. Okay. This is important. I'm still not logged in, but it let me search for, now I'm going to search for beach chair. I need a beach chair like a hole in my head. I have a bunch of beach chairs, but let's suppose I'm looking for a beach chair. This has a fun name. It's an ostrich. I don't want that. I want that to be, I don't know, at least dark. Yay! I like it to be dark, so in case I lose something on it, it's easy to find. Oh, it's unavailable. Of course it is. There we go. Blue and white striped. Yeah, that's expensive. All right, bang, add that to the cart. Great. Now I can go to the cart. Ta-da! It remembers what we do from click to click to click. It remembers who we are. It's tracking my every click. This idea of sessions is not just about authentication and authorization. In fact, it's about tracking the user. It's about identifying the user between various clicks. The HTTP protocol by itself does not handle this situation. The HTTP protocol by itself only handles stateless requests. So how do we connect these two together? I mean, we want to do authorization too. How do we want to do authentication and authorization as well, but how do we do that? Well, we have to have a way of identifying to the server some mechanism that my clicks on Amazon are different than someone else's clicks. So every click, what you call it when we manage state, lots of different ways, but it has to remember us. And so typically the session is existent, right? What it is a two-way link. It's a interactive expression information between two communication devices or ends. Now, usually we're talking about HTTP, right? But HTTP by itself is stateless. right? So the stateless protocol has no mechanism to retain information or status about each user for the duration of multiple requests. Each request is handled by itself. However, some web applications need to manage them, so they have to implement state in some way. Now you can have server-side sessions. Now, server-side sessions where the server remembers everything that you do and connects you to each request. And that's what we talk about server-side sessions. For instance, using HTTP cookies or some hidden variables within web forms. So you could have hidden variables in web forms, and that's how it remembers who you are. Now, is that the only way to do it? No. There are ways of identifying and carrying the information in a token. We'll talk about that separately. And in that, all we're doing is we're authenticating an authorization, providing authentication or authorization to the server via a token. And the token carries the data that we actually want to store. The server does not have it. We're going to talk about those two mechanisms, but those are your two big mechanisms. Okay. So I have this great, and I'm going to share this with you, by the way. So we're going to keep putting these into our folder here and closing them. Now, what is a session and how does it work? Well, in the context of the session, generally is a means of maintaining state about a user's interactions. Pretty simple. The server typically initiates a session when a user logs into a website. Once a user logs into a website, we can identify a session with a session ID. Generally, we pass the session IDs as a URL, we store them in the cookies, or we store them in headers. And that's what allows the server to associate the user request with the session that they're connected to. Basically, the server would then use the session ID to go find the actual information. So the only thing actually exchanged between the client and server is some form of session ID. We can use sessions to provide a personalized experience. We talked about using sessions as a shopping cart. We can use it to track users' mechanism around why did the user click here versus click there. We might be able to track the user's movement through a web page, right? When you think about how Google knows what you're searching for and so forth, it's sessions, right? It's maintaining that information about you. We can use them for security measures as well. And that's going to be our primary, since we're application focused, we're going to generally focus on implementing security measures. When we talked about, and it's going to remind me for weeks to go, we'll go to YouTube Studio, which you can only see my content, right, when I go into YouTube Studio, right? We're going to talk about it from that perspective frequently, but it's used for much, much more than that. So how does it work? So typically you have a login request. You send login user information and the server reads it, identifies if you are who you are. This is the authentication mechanism. And typically the authentication mechanism is literally, quite literally, username, password, whatever. If the server agrees, it creates a session with a session ID and it can access the server using the session ID. So any communication after this, we use the session ID, respond with the session ID, and we connect all those requests to the same user, and then we can track information about the user on the application server. Eventually, we get a logout request, it's a termination request. Usually it involves a confirmation, and then the user is no longer out. That session is no longer interesting, and the application server can dump the information. Now, we can use it for authentication. It's the most common mechanism for using it. Okay. When you log into a site, restricted access, restricted content, you utilize them in e-commerce sites like shopping carts. Anything we need to remember about a user, we can do it. We have advantages and disadvantages. I don't want to talk about most of these. I don't, but I do want to talk about increases the load on the server. The server needs to store and manage session data. That is true. We're going to talk about some mechanisms to attack that, but generally speaking, that is something we deal with. Session hijacking. Servers do a great job of managing this to prevent this by changing the session IDs every so often and so forth, and so on. The big one is the load on the server and the scalability. We'll talk about both of those as we move along. Again, I'm just going to keep storing these in the bookmarks so that you can come back and refer to these if you wish to. All right, I actually put cross-origin request in here because I want to talk about it. I never did, but we're going to come back to that. Okay, so this is session, but it is a ridiculously long one. Okay, so I didn't find this to be that useful. But it does in fact go over session management in massive detail. I'm going to skip it. All right, these are both. Yes. Okay. So we talked about sorry, I'm going to scroll up here. Okay. So we talked about maintaining sessions on the server, right? And that's literally by storing all information on the server that we want to actually maintain on the server. Authentication would handle that way, and the server has the information of what users logged in where and the authentication mechanism and provides all authorization. The server manages it all. Okay. JSON Web Token is a little bit different. JWT is a proposed, I don't know anybody that's has pronounced it JOT, but it's a proposed internet standard for creating data with a signature and encryption, whose payload holds JSON that asserts claims. Now, these are usually signed via private or public or private key. Very important to do that. We'll talk about that why later. However, this is frequently used to be compact, URL safe, and usable, especially in web browser single sign-on context. You can pass identity and authenticated users between an identity provider and a service provider, any type of claims required by business process. Now, what does that mean? You can generate a token that has the claim logged in as administrator and provide that to a client. The client can then use it to identify that it's logged in as an admin, thus can use that as an authentication and authorization mechanism to communicate with the server. We're going to talk about this in a high level context because we're not actually going to do it, okay? Typically, we use this frequently in a identity provider situation, right? So when you're identifying you're a Facebook user, as an example, you may need to use a JSON Web Token, and so forth. Why do we not use this? We'll talk a little bit more about that, but I do want to talk a little bit more about the fact that it has a payload. The payload is a set of claims. There are several fields, names, and so forth. We have roles and authentication, but it's usually used in authentication, okay? And it's stored on the client, okay? Now, what was I going to say? Having said that, JSON Web Tokens will typically contain session state, but if project requirements allow session invalidation, that is a bad mojo. We'll talk about that a lot. Okay. If a user logs out, as an example, there's no way for that JSON token to be invalidated. If somebody has that JSON token and was able to pass that to the server again, they would be able to log in just as a registered users. There's a number of attacks that are specifically designed for, well, all types of things, but JSON Web Tokens are one of them. What you call it? It's ideal to communicate with an identity server, but then we typically would run regular session-based management as well. So, yes. So how does JWT work? Or JOT work? Authentication is done when the client proves its identity, right? It has a payload that has a claim, and that claim proves your identity. Bang, right? So client has to prove its identity. Once it does that, the JWT token includes that. So then that JWT token is on every resource, or JOT token is used on every thing, and the resource that's protected will check its claims to determine if it has what it needs. And this is what this is built on. So this JSON Web Token looks at it and verifies its payload to determine that the JWT is valid for that particular request. If it does so, bang, boom, good. It's a great way to secure information transmission between two parties for two servicers example, because you can verify the validity of the token pretty easily. Okay. If you have any issues with revocable tokens, right? If you have an issue with logging in, logging out, JWT does not work well. Why? It doesn't require any look of the database. So any revocation before the expiration date is very, very difficult. You have no way of identifying when a user logs out, as an example. Revocation is very important in these cases. Changing passwords, example. Right? If the user changes passwords because it's part of the JSON Web Token, if that JSON Web Token is still not expired, they can't do anything until it expires. Sensitive information, it's usually signed to protect against manipulation or alteration. However, can be easily read or decoded. So if you're going to use JSON Web Tokens, you absolutely positively do not include sensitive information in it. So for things involving money or highly secure needs like HIPAA data or like web like health information, patient information, student information, all FERPA requirements and so forth, you can't use Java Web Tokens. Not accessible, not acceptable for those type of interactions. Why? Because those JSON Web Tokens aren't going to be effective, aren't going to be as secure. So it talks about how to use it. But if you're using JSON Web Tokens, you better be using HTTPS. Man-in-the-middle attacks are they're particularly vulnerable to man-in-the-middle attacks. Okay, this says basically the same thing. It goes into a little bit more detail. So I'm going to include that into what JSON Web Tokens are. I think I've covered enough of the explanation. One of the things, though, is it's very scalable. JWTs are super scalable, right? The server doesn't need to remember the client, the JSON token does. And so the server can match it across the JSON Web Token, which is super duper scalable. Problem is, it produces its own issues, right? So I'll make sure that you have this as well. Security issues become a major problem. I think I already put it in there, but I'll double check that I did. All right. Again, this is the same thing. So I did it already. Actually, I did it out of order. I meant to use that other one first. And that brings us to cores. We're going to look underneath the covers before we go into sessions. So we're going to look at the session ID. We're going to look at the headers. We're going to look at the various things that we're doing as a mechanism to, see what we're doing and how it actually works. We'll be using, we won't be using the web browser. In fact, we'll be using the Postman on the server side so we can see the headers and the various things that go across. Unfortunately, lots of tutorials, I just want to include this, lots of tutorials use Java Web Tokens. This class does not have this in any of its homeworks, and that's a problem. You're going to see lots of information about how they're more secure, more scalable, all those things. That is true. But I personally wouldn't put anything that I wanted to protect from FERPA or financial management information in it. Finally, I want to talk about cores. We briefly I'm going to actually stop the recording and come back.